Hello there, I'm Thomas.Hatsios, a German-American pilot flying the Boeing 787-900 to night flight from Zurich International Airport, then we will find Zurich, Switzerland, Germany, then coming back to Zurich International Airport, runway 14 for an Lszh localized at Landung. So right now I'm in the cockpit for the pre-takeoff preparation of the quality wings Boeing 787-900 and Microsoft Flight Simulator X. I'm gonna start seeing the cockpit instruments, the displays and the functions of the Boeing 787-900 jet aircraft. I'm gonna start showing you the primary flight display, the displays the airspeed indicator, the airspeed selected from the autopilot flight director system panel, the ground speed, the radio altitude above the ground level, the barometric altitude above the sea level, the barometric pressure of the outside atmosphere, the target altitude selected from the autopilot flight director system panel, the vertical rate of climb descent of the aircraft in tens, hundreds and thousands of feet per minute. All the signals of the trigonometric angles in decrease can climb and descend. We have also the artificial horizon with the altitude indicator and the pitch ladder in degrees, the bank angle in degrees, the Lszh localizer, the horizontal localizer and vertical glide slope that receives the radio frequency transmitters from the airport threshold antennas of the instrument landing system, the Lszh localizer, so we can align the aircraft in the air for takeoff and for landing. With the Lszh localizer frequency, horizontal, neither vertical glide slope. You can see also the frequency. We have tuned either manual or automatic. So we have the Lszh airport, the Zurich International Airport in Switzerland, and the runway 14 frequency for that, and the magnetic north pole heading of the runway 14 of 136 degrees for alignment. So we have the Lszh localizer crossbars, the flight director crossbars for manual guidance of the aircraft, and the autopilot crossbars for automatic guidance of the aircraft. We have also the angle of attack of the aircraft as it flies and the flight mode and zero with the autopilot and the auto throttle. Later on vertical navigation modes, we have also the HSI, the horizontal situation indicator that displays the magnetic heading and track, the magnetic north pole and true north pole magnetic variation depending on where we are in the world. So we have also the navigation display. In the HSI also we have the standby flight plan display, the decorated display of this flight plan. I'm gonna show you later when I'm gonna create one using the flight management computer. So I'm gonna use the flight management computer to create a flight plan or a flight path or a route for the aircraft. So we have the navigation display. The navigation display the GPS position of the aircraft, inertial reference position, the magnetic heading and track, the magnetic north pole and the geographic north pole, and the magnetic variation depending on where we are in the world. We have the terrain weather reflection from the weather radar. You can see the weather and the terrain displayed also with red, green and yellow colors, also the blue for the sea and lakes and rivers. So you can see the elevation, the horizontal, the vertical profile. When you're flying to avoid the terrain in front of you or around you. We have also other aircraft that fly around us displayed using the transporter. It is being ADC transmitter receiver that transmits our frequency to other aircraft and the traffic control and receives from other aircraft and can display the other aircraft position, direction, altitude difference from our aircraft, whether they climb or descend with respect to our aircraft. Also you can calculate the velocity closing in between our aircraft and the other aircraft when it's an incoming collision. It will give us a warning of the TCAS system, the Traffic Collision Advisory System. So we'll make an avoidance maneuver in flight. So we have this makes computer makes calculations about the other aircraft position and direction and altitude. So we have also we have the terrain map with the airports. You can see the airports where they are located. Our own airport right now, the Zurich International Airport, and the runway we're gonna use for takeoff and for landing. Runway 14 or the other one, runway 16 is beside us, the taxiways. You can see the GPS display. We have also the airport's names with the blue display in 4 letters code name, and we have also the navigation aids, the nav aids, the ADFs, NDBs, transport ADBs and road stations, ADFs, and the waypoints. The waypoints, which are horizontal vertical navigation fixes, the aircraft will gonna have to fly through some waypoints we have selected. You can see the star displayed in the navigation display. We have to follow these waypoints. In flight, we're using the flight management computer. I'm gonna show you in a couple of minutes. We're gonna create the flight plan. Over here you can see we have the primary flight display with the airspeed indicated, the barometric altitude, and the airspeed selected and the altitude selected. Also the autopilot flight director system panel, navigation display, engines display, flight management computer here, flight controls over here. You can see how I'm gonna use the flight controls later. How input using the side stick. We can change the direction of the aircraft in flight. We can change also the thrust over here, the thrust levers. You're gonna see how we use them. The flaps and the speed brakes over here. The speed brakes, flaps and slots. Fuel control for the left and the right hands, fuel flow. The flight management computer over here. So I'm gonna create a flight plan in a couple of minutes. You will see the way I'm gonna do it. Then the overhead panel of the systems, I'm gonna make an engine start demonstration. So you're gonna see also the engine start demonstration of the aircraft, of the Boeing 787. I'm gonna shut down the engine to restart them before making the flight. In the other part of the video, you're gonna see the complete flight from takeoff, climb, cruise test, and approach and landing. We're gonna use also the flight management computer, as I told you, to create a flight plan or a flight path or a route. I'm gonna input all the data of the aircraft for this flight and include the empty weight plus the passenger plus the cargo plus the fuel on board. So we're gonna have the takeoff gross weight. So we have the flight management computer is gonna calculate where the fuel is stored in the left and the right wing. How much we have it right now, 30% in the left and the right wing, and 10% in the center tank. So it's gonna make calculations about the center of gravity of the aircraft. As it flies, it burns fuel, so the center of gravity is shifted. Also, it's gonna calculate the loads from the passengers and the cargo. It's gonna give us the center of gravity for takeoff. And then in aerodynamic chord position of the forward wings is 23% of the Mach with respect to the center of gravity. It's gonna give us is the position with the maximum aerodynamic lift reduced in the forward wings. Is also the position where the stall will begin in the top surface of the wings. The airflow will become detached, so we need to monitor over here. We have the airspeed indicator, as you can see. We need to monitor the airspeed as we fly. It needs to be always higher than the stall speed. You're gonna see a yellow and red indication below the airspeed. Also flaps and never exceed speed. You can see the pitch ladders here in degrees: 2.5, 5, 7.5, 10, 12.5, 15, 17.5, 20. For pitch up or pitch down, the bank angle also as we fly. The vertical rate of climb descent. You're gonna see this needle, white needle, is gonna move up when we climb and down when we descending. So you need to pay attention to that to know whether you climb or descend. Radio altitude, how many feet we are above the ground and how many feet we are 1430 above the sea. Elevation with this barometric 29.92 inches of mercury. Radio minimums. The flight mode annunciator also, the takeoff go round. So we can set the barometric pressure here, inches of mercury, hectopascals. Also select the minimums and the plan here and the rates of the navigation display. We can change the settings of the maps displayed from the navigation display and the navigation aids we use. Also you can see the engines here. I'm gonna talk to you later, the left and right engine. The flaps position, the horizontal trim stabilizer, some other indications. Also you can see the autopilot flight director system panel display here, 200 knots and 10,000 feet, and 360 degrees is the heading here with the purple line. This is 0 or 360 degrees is the same one displayed over here in the autopilot flight director system panel. We have 200 knots. When we change something, it also displays in the navigation display. Autopilot engage, disengage, flight director engage, disengage, auto throttle, left and right. So we have the airspeed guidance, the heading guidance, the vertical rate of climb descent of the aircraft, and the altitude selected. VOR localizer approach for auto land, also function of the Boeing 787. So we have a few more things here. You can see the displays later. Systems display over here, CDU, info checklist, communications, weather radar, traffic, terrain on the display. You're gonna see all this in the flight plan here, then navigation display. So we're gonna go for the flight plan. So I'm gonna use the takeoff gross weight as I told you. It's gonna calculate the center of gravity, the fuel on board, left and right wing, center tank, the passengers and cargo loads. It's gonna calculate the center of gravity, mineral dynamic core position, 23% of the Mach. This also is gonna give us calculations about the horizontal stabilizer, the horizontal tail of the aircraft. We're gonna trim it during the whole flight, trim up and trim down. The horizontal tail will give an effect in the nose of the aircraft. It's gonna make it pitch up or pitch down, so you can see the trim nose up or nose down over here. We have it in the control wheel, also in the horizontal, in the alternate trim in the pedestal next to the engine's thrust levers, and the auto trim disconnect switch. So you're gonna see here, I'm gonna talk to you a little bit aerodynamics later, Newton's physics. You can see we can trim the horizontal tail of the aircraft up and down when we fly like this. It's gonna change its position. You can see also we have the elevator here. We can climb and descend, make turns left and right, also the rudder pedals. So you can see here is we have the aircraft wings hold the weight of the aircraft as it flies. The mineral dynamic core position is 23% of the Mach, where the maximum dynamic lift occurs. Is also the position where the stall will begin in the top surface of the wings. We have here mineral dynamic core 23% of the Mach, pretty much close to the center of gravity. So we have the lateral axis from wingtip to wingtip, the longitudinal from the nose to the tail of the aircraft. That affects also the turning, the pitch attitude. We can climb and descend like this using the elevator, and the rudder make turns left and right, the ailerons and the spoilers. So you have the thrust from the engines propels forward the aircraft. You can see the vertical also axis from through the center of gravity. So we have the bottom surface of the wings. You can see using the Bernoulli fluid is more flat. So there is using the Bernoulli fluids. We have also the curvature from the flaps and the angle of attack when we're gonna be flying. There's gonna be the airflow is gonna be moving slower below the wings. So we're gonna have higher pressure below the wings. We're gonna pressurize the aircraft wings and weight up into the air. Also, you can see the top surface of the wings has higher curvature, so as we're gonna be flying using the Bernoulli fluids, the airflow is gonna be moving faster above the wings, so we're gonna have lower pressure above the wings. We're gonna suck the aircraft up into the air, the weight and the wings. So you're gonna see also that the spoilers and the deflection from the flight control. So this is Newton's physics, aeronautical and aerospace engineering principles we need to know for the air transport parallel license. So I'm gonna show you now how to use the flight controls. After I'm gonna make the flight management computer, I'm gonna create a flight plan right now. Then I'm gonna show you. So as I told you, I input the takeoff gross weight. I select the runway. We're gonna use the Zurich International Airport, the runway 14, the runway length, the runway slope, the wind direction and speed, the barometric pressure, the density of the air, the temperature of the air, whether the runway size dry or wet. This is gonna calculate. We're gonna use 15 degrees of flaps for takeoff. So the flight management computer is gonna calculate using the mineral dynamic core position, 23% of the Mach, and the horizontal trim stabilizer and the center of gravity is gonna give us the takeoff speed V1, we rotate, and the V2. And we're gonna have the takeoff speed V2 plus 15 knots, like 160, 170 knots. The climb, we're gonna use like 9 degrees of pitch attitude for rotation or less, like 7 or 8 degrees for the takeoff roll. Also for approach and landing, we have the seats. We're gonna insert the seats. The seats are the standard instrument parts of waypoints and fixes that include horizontal vertical navigation fixes for the initial climb of the aircraft. Then the top of climb to the cruise level. We're gonna cruise like 25, 36, 27, 28, 29, 30,000 feet above the sea level or the airport elevation. We're gonna have to transverse through some waypoints: the Zui, the Negria, the Amity, then the Zuidian. You're gonna see the waypoints I'm gonna select. The TRA ZH 701, Also then we're gonna have the after we're gonna cruise, we're gonna have the top of descent. We're gonna start descending. So we're gonna have the descent to the stars, the startup terminal, arrival waypoints and fixes, the stars of the Zurich International Airport, runway 14 again. So we're gonna use this approach for landing. We're gonna have the horizontal and vertical navigation fixes for the terminal approach and landing, the long final and the short final, gonna align us with the runway heading. We're gonna use magnetic northpole heading, and also the Lszh localizer, the instrument landing system, as I told you, that receives from the onboard antennas of the aircraft the frequency transmitted from the antennas of the airport. We're gonna be aligning us with the horizontal and vertical navigation frequency of the Lszh system of the Zurich International runway 14. I'm gonna use flaps like 25-30 degrees, an airspeed 160-170 knots, and a pitch attitude of 9 degrees, and lift gliding gear down for approach and landing. So you're gonna be aligning with the Lszh localizer. We're gonna fly manually the approach and landing. So you're gonna see all these things. We're gonna have a complete flight plan or flight path route. I'm gonna show you right now. We can tune also the Lszh frequency using the flight management computer automatically when you select the runway we're gonna use for takeoff and for landing. The runway we have selected the same. So also we can tune it manually using the radio management panel. The navigation radios over here, you can see some selections we have, so we can tune the Lszh localizer, VHF, HF, SAT, CAP, TPWX, XP, transporter, active, VHF. So we have over here. So you're gonna see how you're gonna use all these things. We have also the mouse pad here to control the cursor of the indications here, you see. So I'm gonna use the flight management computer now. I'll set up the flight plan. So you can see another view here of the aircraft. So you can see we have the index here, the functions, the modes, identity, position, performance, takeoff, approach, announced status, navigation data, flight plan, flight plans, load ATC, route, load plan, save plan, save flight plan. So we have position here. We're gonna use the reference position, Lszh, Zurich International Airport, Zurich, Switzerland. It's gonna give us the GPS coordinates here, the nearest one. Position, the identity, the model, and the engines. So we're gonna have initialize here, the performance initialize. We're gonna use the route here, origin, departure, and destination. So we're gonna use Zurich International Airport, the Lszh in Switzerland. Departure and arrival over here. Same departure, same arrival, origin and destination. So we copy paste, and we use runway 14 over here. So we're gonna use runway 14. Route, departure, arrival over here. So we use the departures page over here. You can see departure, arrival, index. So we have select 14. We can select either one, 16, 2832, 10. So we have 14, Zurich to Alpha. These are the seats that are arranged by departure, waypoints and fixes. Then we have departure, arrival. Arrival, select Lszh again. We can select Lszh 14, 16, 10, 32 again, 28. So we'll select Lszh 14. We can select VOR also. We'll select the trans waypoint Amity, and then we're gonna have next page here. Select Negria Uh, so this is the stars. As you can see, the stars are the starter terminal arrival waypoints and fixes over here. Select fully wireless approach. So horizontal vertical navigation fixes. So we have the route created almost. Here you can see the legs of the route from takeoff, climb, cruise, descent, approach and landing. We have to cancel out discontinuity. Then we go in the performance initialize. We have the zero fuel weight plus the fuel on board, 322 plus 35. We have 358,000 pounds. Over here the gross weight we use the reserves 5%. The cruise altitude 35,300 for this route, and the cost index 100%. Over here we give us a center of gravity in flight 28%, and a cruise fuel temperature freezing at minus 37 degrees Celsius in flight. So we need to recirculate the fuel in flight to heat it up. So you can see some messages here: destination, airport, format for characters. So we press the execute here, as you can see. If you go here and press the execute, you will see the magenta turn on, the purple color. So now this is an active flight plan, so it can be followed either manually or with the autopilot. If we turn on the autopilot, we can use this flight plan to fly the aircraft in the LNAV and the VNAV function. So you can see from takeoff we have the intercept, first waypoint, second waypoint, Zui 302 knots, 6000 alpha, 6 nautical miles away from the runway, heading 0.52. The first one is same heading like the runway, 135 degrees, and 250 knots, 1900 alpha. Then we have Nigra. We climbed 26 nautical miles heading, and 302 knots, flight level 22,100. Motive. Then we start the descent 12 nautical miles away, 320 knots, 11,200. Amiki 190 knots, 10,400 feet. Zui 180 knots, 7,000 alpha. Z870 we have the long final approach here for the runway for approach and landing, 6,000, 7,000, 6,000 feet. The Zui TRA 108 knots, 5,000 alpha, 10 nautical miles away from the last waypoint. 6 nautical miles away is C11 CI14, 108 knots, 4,000 alpha. Oznem, you can see the heading is gonna be now same like the runway, 5 nautical miles, 174,000 feet. And the last waypoint after Oznem is the runway 148 nautical miles from Oznem, same heading, 135-36 degrees, 140 knots and 1,430 feet. You can see the takeoff go around. Then we have some other waypoints with blue the legs. So we have hold also, we can hold here in flight, select some waypoint, hold over here. FMC communications, progress, this progress, active, alternate, VNAV, departure, arrivals, route, initialize, fix, we can hold, also have a fix, and navigation radio over here. So we have initialize, again we need to use 15 degrees of flaps. This is the takeoff reference. We have to press this button here to give us the center of gravity for takeoff, and the trim stabilizer of the horizontal tail 4.25 degrees, 33% of the center of gravity. This gives us V1, V rotate and V2. For these flaps we selected 15 degrees. This gross weight in this runway, length and slope. So this is the takeoff data. We go back in the index if we need. So we're gonna have the flight plan here displayed. I'm gonna show you the navigation display, the primary flight display, what it is showing us in a couple of minutes. So I'm gonna show you also the flight controls. So we have the display here. You can see the data, some things here. Takeoff, go run, a flight director. We're gonna have now the flight plan here created in the displays. So you can see this integrated display of the HSI. We have the waypoints. We have the runway here displayed, takeoff, climb, cruise, descent, approach, and landing here. You can see the first waypoint is the intercept, 1.6 nautical miles. You can see here the purple adjust the line in the vertical here as we're gonna take off and climb through these levels, like 16,000, 32,000, 40,000 feet above 0 feet is below us. And you can see the vertical white lines is the waypoints we have to cross. You see them here displayed in the horizontal map. We can change the view here, the range, like this. Zoom in, so you will see zoom in. You can see the runway here displayed. We have in the right and the left the runways and the taxiway where the aircraft is oriented right now. So if you look in front of us, you see the taxiway and the runway, just like in the GPS display here. So you can see here the runways we have in the taxiway. So you use the GPS also display, the navigation display for navigation. We have the terrain also around us. You can see in front, like we have like 5 nautical miles away some mountains displayed over here. We are 1,430 feet. So you see the mountains over here in front of you, to this side. So we need to also have some horizontal view over here, increase the range. Further away you can see the approach and landing fixes here, the takeoff this way, and the runway. So the runway also displayed like this. The approach, look a little bit further away, you will see how we're gonna climb. Over here you can see the terrain also, yellow, green, red colors, blue the sea. So you can see here is the climb. We have to cross through these waypoints, make a turn. First turn is left, then right turn, then another right turn, then another right turn, then a left turn. Over here, approach and land. So we cross through all these waypoints you see here. Over here they're displayed with these stars over here. We have to cross through. So you see even further away, you see more airports. You see some airports in France and Germany. So we have the stars also indicated here. You can see the star sign, like the TRA CI 14 Z8701 Osnan over here. So you can see the slope also we have to climb through. A few more navigation, the plan also over here. So you see map centering here, some other information. You can see the elevation right now for this range is 3,200 feet and 1,600 the minimum, and the maximum range in front of you, this direction. You can see this terrain approximate information. So we have the runway again, the climb, cruise. Then you can see the range over here. We have to cross through the waypoints here, the other airports further away, like in Germany and France over here. So we look closer, you will see again the stars over here. We have to cross through. Then we look closer, you will see a better view. This is the takeoff departure over here, and we make some turns in flight like this over here, and then there's an approach and landing. So you can see the runway again, how far away we are from the runway in nautical miles, the rings over here. So this is all we need to know. We can fix also some other, we have the maps, some other indications here. This is navigation display, so we're gonna change the indications of the autopilot also. Later we're gonna see some systems, the engine. So I'm gonna talk to you now maybe about the flight controls of the aircraft. So I'm gonna show you the flight controls of the Boeing 787-900 jet aircraft. I have this side stick that loads the Extreme 3D to use the flight controls. So you're gonna see how I'm using the side stick to control the horizontal tail of the aircraft, the horizontal stabilizer, the elevator, for climb and descent. Also we have the horizontal stabilizer trim. You can trim the horizontal tail of the aircraft, trim up and trim down, to pitch up and pitch down the aircraft nose in flight to balance the aircraft, and also relieve the air pressure from the side stick from the yoke of the Boeing 787, the control column, the control wheel as we fly, and the rudder pedal. So we have all these flight controls. So you're gonna see I'm using the control column to climb and descend, the control wheel to make bank rolls left and right, and the rudder pedals. We have the rudder pedals to make nose wheel steering in the ground. Yawing turns in flight, we use a vertical rudder. Is active, aerodynamically active above 45 knots in takeoff. Also we have the nose wheel steering from the tiller is interconnected with the rudder pedals until like 76 knots is becoming deactivated. It's decreasing from 76 degrees deflection to like 7 degrees at about 40 knots, then to 0 degrees at 70 knots in takeoff. So you're gonna see I'm gonna use all these flight controls here. Use the side stick for climb descent. You can see make turns left and right. We have the horizontal trim stabilizer over here. I will talk to you the switch, the autopilot disconnect, the head up display declutter. So you're gonna see a few more things. So climb and descent, you use the elevator like this for climb and descent. You see the tail moving up and down. Also make turns left and right. So this is how you use the elevator. Using the side stick, you can climb and descend, you can make turns in flight. So you can pick up how many degrees you want to climb descent, and using the thrust also, propulsion from the engines, rudder pedals as I told you, use the vertical tail, the rudder, use this for the horizontal tail, climb descent, make turns left and right. The control wheel over here is the control wheel section. You use this to make turns using the ailerons and spoilers and the flaperons. So you can use either one or rudder pedals, or use them all together. You will see what happens with the rudder pedals, for instance, or the yoke. So we have also the thrust levers over here. You can see moving thrust forward and aft. The tiller over here, which is interconnected with the rudder pedals. You can see we have the flaps and slats position over here, so we can retract over here if we have them extended all the way up or all the way down. Extend again the flaps, see how many degrees you have, like 30, 25, 15, 10, 5, 1 or 0 degrees. Fully retracted. The speed brakes also external retract. We have the fuel control for the left and right engine. I will talk to you now. The thrust levers over here, the auto throttle disconnect switch. You disconnect the auto throttle with this switch, takeoff, go arm switch. So we have the throttle control, auto throttle disconnect switch, thrust reverse. So you see the thrust also, the speed brakes as I told you. So you extend the speed brakes like this, and use the thrust levers over here. You will see how much thrust you have produced over here in the engines indications, the left and right engine. You can see the commanded position right now is forward full takeoff thrust. You can see the configuration, the warnings now, and the occasions. It takes like 2 or 3 seconds for the engines to react to reach its anticipated commanded position from its actual position. So I'm gonna show you a few more things. We did the displays, we need to do the flight controls a little bit more in detail. So I will show you another view of the flight controls. I use the flight controls to control You can see here I can climb descend. You can see the side stick deflection is proportional to the yoke deflection of the Boeing 787 and the control wheel and the rudder pedal. Also, both captain and first officer flight controls are interconnected and move together in flight. Unless we have a failure, not like in the Airbus, you have the side stick priority button. You can use either side. So also we have the thrust levers, as I told you here, and the horizontal trim stabilizer. The switch you will see just after. So I'm gonna keep explaining a bit more, and you will see also another view over here of the flight controls. A better view. So you can see we can climb the descent like this. We can make turns to the right, turns to the left, use the rudder pedals, use either, use neutral in flight. So you can see how it looks like. We have the horizontal trim stabilizer also. So we have the thrust levers also over here. So I'm gonna show you now one more thing. The outside view over here. You can see left and right turns, rudder, elevator, climb, descent, like this. So retract aileron spoilers, make turns left and right. So this is so much for the flight controls lesson right now. I will show you now the rest of the systems before making the engine start demonstration. So I'm going to show you a few more systems now inside the cockpit before making the engine start demonstration. You have to see the horizontal trim stabilizer first, then a few systems over here in the displays. So we have the horizontal trim stabilizer. This switch you can trim, as I told you, the horizontal tail down or up, nose down this way, nose up the aircraft the other way. So you can see this way is nose up, this way is nose down. So we have also autopilot disconnect over here. So you can see elevator trim, left click down, right click up, autopilot disconnect, and head up display. So you use this to trim the tail of the aircraft as you fly up and down to balance the aircraft. Also you can have here we have the autopilot flight director system panel. This is a fly-by-wire aircraft, so it has a fly-by-wire side stick, yoke actually, and flight controls input. So we have the rudder trim here. Also in this section the fire extinguishers for the left and the right engine, the transporter, radio and communication panel. So you pull out and switch the fire extinguishers. We have the fuel control for the left and right engine. Also we have the elevator trim, nose up here, the alternate, and nose down. So you trim up like this, the aircraft nose trim down the other way, pitch trim down or pitch trim up, just like you do with this trim switch. So you trim the tail up and down in flight. And you can also use as you can see, we have the parking brakes also here. We have the stabilizer trim cutout switch over here, this guarded switch. You can see we open from normal to cut off, L2 and R2, hydraulics elevator trim position. So we have elevator stabilizer cutout switch guard. So we open and move from normal to cut off. If we have a failure of the L2 and R2 or either one hydraulic system, we can disconnect either elevator left and right, horizontal stabilizer, horizontal tail from normal to cut out, and we can have the auto trim function disconnected from the autopilot flight director system panel, because we have automatic trim from the fly-by-wire system, flight management computer, in the auto throttle, flight director, and autopilot. So we're gonna use only the manual trim switch after. Over here we can trim using manual hydraulic power. So a few more things to see here in the cockpit. We have the displays here, as I told you, autopilot flight director system panel, the engine indication. You can see we have the left and the right engine. We have the flaps position, as I told you, stabilizer trim, rudder trim, landing gear external retract. Over here, this landing gear alternate also gear. Over here, we open this guarded switch and lock override. We have the parking brakes, rejected takeoff over here. Parking brakes, set parking brakes, auto brakes actually. So we have the auto brakes at 1, or RTO. We have RTO now, rejected takeoff, just like here in the auto brake selection. So we have the standby instrument display here. We have the gross weight of the aircraft, saturated and temperature, total fuel on board, and the fuel temperature right now. So this is all we need to know about the cockpit instruments, main functions. Pretty much a few more things left, like the engines. As I told you, you have the N1, which is the low speed starter sub low pressure compressor and turbine with the turbofan hypothesis engine, left and right, 104% for the takeoff limit, the green needle. Over here, yellow and red, never exceed. Exhaust gas temperature per engine, left and right, and 2, which is the high speed starter sub high pressure compressor and turbine. Over the turbofan hypothesis engine, fuel flow per engine per 1,000 kilograms, so 1,000 pounds, left and right. 1,500 right now per engine per hour. Pounds oil pressure, oil temperature, oil quantity, and the vibration of the N2 stage of the engine. So we have over here, as I told you, the engines. We have the thrust levers, as you can see. We can move forward enough. It will display N1 exhaust gas temperature. So we have the GNX engine installed in our Boeing 787-900 aircraft. On the left wing, on the right wing, for symmetrical thrust and redundancy. Each one contains a gearbox with the FAREX. The FAREX are the full authority. These electronic control computers. One is all parent gearbox. Dual channel redundancy. One channel phase, the other takes over. Control consoles can display all the engine data using the upper and lower ACAS and execution control system display. Also the multifunction display. We have the N1, which is the low speed starter sub low pressure compressor. All the turbine of the turbofan engine, the exhaust gas temperature per engine, the N2, which is high speed starter sub, the high pressure compressor, and turbine of the turbofan engine, the fuel flow per engine per 1,000 kilograms, 1,000 pounds, oil pressure, oil temperature, quantity, vibration of the N2 stage of the engine. The FAREX also control the bleeder from the 5th and 9th stage and from the front fans bypasser. So we turn on the bleeder from we can turn actually the pressurization panel over here from auto to manual. Over here you will see what it displays, manual with amber color light, and also over here will give us some warnings, cabin altitude, outflow valve, aft and forward, and it will give us the position of the valves, cabin altitude, rate of climb descent at 8,000 cabin altitude. We're going to be flying at 40,000 feet above the sea level. Differential pressure, landing altitude, differential pressure is going to be like 7.88 psi. So the FAREX control the pressurizer from the 5th and 9th stage. We need for cabin pressurization, we can add the ice air conditioning, ventilation, oxygen regulation in the cockpit of the cabin. Also we need hydraulic fluid pressurization. We need the pressurizer from the engine, so the APU and turbine to pressurize the hydraulic fluid tanks. So you can see here all the flight controls. We move around, utilize the elevator, landing gear, external retract, the rudder, elevator, spoilers, ailerons, flaps, speed brakes. So we need the landing gear, external retract, parking brakes, thrust reverser for the engine, flaps and slats, tiller, nozzle string. So we need a hydraulic fluid over here, pressurization from the pumps we have the engine drivings and the electric drivings, and also pressurizer with the engine APIs, as I told you. So we need also, if we have an overpressure or an underpressure, the fabrics can control it, open and close the outflow valves in higher lower position. Also the fabrics control the fuel metering unit, fuel flow to the engine, and the starts in failure. Also the oil heat exchange sensor. We need to heat the fuel in flight because it's gonna freeze, so that we use the fabrics that are controlling automatically the fuel exchange sensors and other circulation of the fuel from the fuel tanks into the engine components to duct heat from the engines and heat up the fuel. Also we do the same with the lubricant and oil. So we need also, as we take off, climb from the sea level, like climb up like 20, 30 or 40,000 feet above the sea, or the elevation of the airport, like 9,000, 10,000, 11,000, 12,000 meters above the sea level. As we climb higher, the pressure of the air, the temperature of the pressure of the air, the density and the oxygen level become less than half than that of the sea level. Also the temperature of the air becomes freezing, like minus 20, minus 30, minus 40, minus 60 degrees below 0 in Celsius. So we're going to be also flying with an airspeed rate 2 or 3 times faster than that of the sea level. So we're going to have a higher intake of air from the front fans for combustion and compression into the engine. So this is also controlled automatically from the fabrics. The fueler makes your request. Also, as we descend back to the airport, so it's a good thing to have the fabrics installed into your engines. I'm going to show you also the APU. We need to start the APU to start the engines in electric power battery over here. So we start, we have the contactors left and right engine driving, IDG, the great drive generator, 120 to 100 volts, 400 Hz frequency, 130,000 kilovolts, primary flight control computers over here in the auto position. Over here, air data computer contains IRS, inertial reference system, GPS receiver, pitot static, pitot dynamic, all the airspeed you see, altitude, rate of climb, descent of the aircraft is controlled automatically. Also the laser gyroscopes of the aircraft, flight control surfaces, powering power, FT door, passenger oxygen, window heat, rammer turbine over here, hydraulics. If we turn off left and right engine driving, you're gonna see the fault here displayed. We turn back on. So this is the overhead panel. Also we have this is the lighting system, windshield wipers, wing and engine ADIs over here. Turn on or auto position. We have the recorders over here, fire extinguishers for the APU and cargo, electronic engine control for the engines, normal and alternate mode, and the auto start here when I use later. Fuel jettison, we dump some fuel to lose weight in flight, and select, if we arm this, and select the nozzles and how much fuel to remain. Left and right wing fuel tank, center tank, fuel booster pumps over here, cross-feed valve. You can balance fuel from a left and right wing. Also feed either engine with other pump or either tank, the balance also here. So we have the pressurizer from the left and right engine packs, and also the cabin pressurization system. Here in the manual we use the outflow valves for climb and descent, and also manual in the auto. We don't have to do anything, it's all automatic. So this is the overhead panel. Before going for flight, we need to set also over here a couple of things. Autopilot engage, disengage switch, auto throttle, left and right, flight director on off. We cannot arm anything with the flight director off. We need always flight director on. So the airspeed here, we're gonna set the airspeed like 253. We have flight level change, climb continuous, auto throttle, autopilot disengage like this, auto throttle off, left and right, bank angle in flight, heading, we're gonna use magnetic north pole heading, 136 degrees. Over here, the altitude over here, 25,000, like this. thousands, and then hundreds. Also we have the vertical speed, flight path angle, zeros. We can descend like this, you will see what happens, or we can climb the other way, like 3,500 feet per minute. This will be giving us a display over here. In the primary flight display, all the indications we have selected from the autopilot. So we have one last thing to do before flying, the systems display. Over here, all the systems using the overhead panel. I'm gonna show you. Now everything is normal. So we have over here systems, hydraulic, APU, oxygen, liquid cooling. We have the electric over here, left and right, IC, the grid drive generator, 120 to 100 volts for 100 Hz frequency, battery voltage over here, 28 31 volts, battery and APU, hydraulics, left and right engine, electric C1 C2, 5100 psi, its pressure, and where the hydraulic fluid goes over here. Also the fuel on board, left and right wing tank, center tank over here, low and high pressure, fuel bus, left and right engine, 11,000, total 34,000 pounds. The cross feed valve is off, we turn it on, can feed either engine with either pump or either tank. The APU is fed from left wing using the DC motor. Also you can see here minimum fuel temperature. We need to recirculate the fuel to the engines to heat it up. It's minus 37 degrees Celsius, so we use the recirculation for heating up the fuel in flight. We have bleeder from the box APU, from the engines. The doors are closed, the cabin can be pressurized. The gear, you can see the pressure of the tires and the temperature of the brakes. Flight controls over here, you can see everything is working. All flight controls are moving normally, left and right wing, also the elevator, the tail of the aircraft, the rudder. Also we have FE's display, maintenance and circuit breakers. And we have one last thing before making engine start demonstration, the checklist here. Normal menu, what we do before start, before takeoff, after takeoff, descent, approach and landing. So we go back, navigation display. So we turn off both engines over here. You can see both engines, fuel control off. So you see the engines are off right now, are slowing down. Over here you're gonna see some yellow indications are popping up. So we're gonna restart the engines very quickly. We need to go in the overhead panel, set up both starters, auto start here in the auto, left and right engine. You see the indications, their configuration in yellow with the switches. And let's think, we're gonna have pressurizer right now, 19% of the N2, 20%, above 20%. We can feed both engines with fuel. So we turn both fuel control on very quickly, as you see. So this is very fast engine auto start system. This is the auto start is kicking in, 38%, 40. So you're gonna see now the systems with yellow, they're gonna turn off, they're on actually. So auto start is on, 59, 60% we're gonna have running both engines. So here we have them running engines, and we can go for takeoff like this, flaps for takeoff, 15 degrees, and also this view for takeoff, and take the clearance, advance the thrust levers, parking brakes off. So we taxi into the runway right now. We use the tiller also. So the runway is open for us for takeoff. So we advance over here the thrust levers to take off Goran and go. Aligning also with the rudder pedals with the center line. So we have 100 knots, 130 V1, we rotate like this, so slight rotation. And we have the positive climb. We pitch up a little bit the aircraft. You see the indications are correct. So landing gear up, I believe. Landing gear up. So keep climbing like this, as you can see. We are 2,400 feet above the ground, 3,000, 4,000 feet above the ground, above the sea level. Climb with 4,100 feet per minute. Over here we have the airspeed 170 knots, the stall speed here with the yellow and red, the markings also. So you can see the terrain around you, and also below you. We need to pay attention to avoid the terrain with green right now displayed, because it's way below us. You can see how far above we are from the ground as we keep climbing. Also we can use, we have the engine indication also to pay attention. A bit more range over here. You will see the red, green and yellow, better terrain, deflection. So we're gonna use a shorter range for the flight line over here. We have the head-up display. So if we look outside, you can see we have a nicer view from here, from the Switzerland, from the Swiss Alps as we climb. So we need to make the turn now to follow the flight line. So use some left rudder. So we are leveling off here. You can see we can fly with hands off like this. There's no problem. The aircraft keeps flying. It's well trimmed, as you can see. So we can use this display, have a better view of the flight plan also as we keep climbing. You can see better view now of the Switzerland, the lakes over here. Other aircraft that fly close to us. We can also retract some flaps. We're gonna increase the airspeed rapidly. You're gonna feel all the change when we retract the flaps, but we need to increase the airspeed. So now perhaps we're gonna be accelerating to higher airspeed, 220 knots. So this is a nice view of the cockpit just after takeoff. And the view around us. So we have also indications again, head-up display over here. You can see autopilot is connected this way. So we need to make a small turn now over here. Keep climbing, 19,000. We need to align with the flight plan here. And we have 11 more minutes left for this flight. So 21,000 feet. So here we are flying 21,000 feet, overflying the Switzerland, the Galaxy also. We have the lakes, beautiful lakes of the Switzerland, the Bayern Munich, the Germany in front of us, my homeland. So have the beautiful Boeing 787 here. Keep climbing. Beautiful Germany view and France over here. So we are 23,000 feet. Gonna be having a start turning in a couple of minutes. 24,000 feet. You can see the stall speed. You can extend some flaps over here and make start the turn back to the airport. We have a few more minutes left. So you can see we overflying the lake here in Germany, and the France, the Italy in this side, the Switzerland, the beautiful lake here, Northern Lake. You can see the Boeing 787 making the turn here. Overflying 24,800 feet. So we need to keep turning. Also, like 9 more minutes left for this flight. 25,400 feet. Keep turning. We're gonna reach also the altitude. We're gonna have the handrails. So you see how we follow the flight plan here, the lines. Also pits up the aircraft a little bit. So this is the final alignment here, and we have 8 more minutes left for approach landing. So we are 26,000 feet right now as we making the turn. We need to align with the flight plan here. Right rudder right now, right rudder pedal. Now ailerons, left side, balance with the elevator. So we are 36,400 feet. We have the frozen vapors right now from the engines, very beautiful frozen vapors over here, the France. So we need to start descending also back to the airport. Idle thrust, retract and we have 7 more minutes left. Retract also the speed brakes. Retract actually the flaps, extend the speed brakes, idle thrust. You can see nice view here as we are flying closer. We have the Galaxy also, the Germany behind us, the France. And we're at 34,000, we need to keep descending. Need to accelerate the descent like this. And we're following, as you can see, the flight plan, the stars here. We need to follow for approach and landing, and we have 6 more minutes left for the approach and landing. I think we have enough time for approach, so we can hand fly a little bit better. You can see the runway on this side, the blinking lights. Keep pitching down. You can see the waypoints we have transverse through over here. So we're following this approach and landing modes here. We have the terrain, and we have also the approach here. We're gonna make a left turn. The airspeed is decreasing right now. Also the other side, you can see we agree. Also autopilot for vector system panel and the head-up display. So we are very close to TRA, CI, and 4. We need to start turning. We have 4 more minutes. Increase the rate of descent also. So we make the turn now for the approach and landing. So we're gonna be approaching like this the airport, as you're gonna see. Left rudder pedals, and we have 3 more minutes left for approach and landing. So we have landing gear down, flaps also. Start extending the flaps, a bit more thrust, and we are very close to the runway. We have 2 more minutes left for approach and landing. We need to align like this. So we're going to be using this view over here for alignment. And for landing. So we have 2 more minutes. It's okay, we have enough time for approach landing over here. So you can see also the Lszh localizer, all the indications, all the information is correct, the engines also, indication, the airspeed, how far above we are from the ground. So we need to align a little bit more. Over here we have 1 more minute left for this landing. Also use full flaps right now. So we have some side wind, we need to balance the aircraft using the flight controls, a little bit more thrust up, and we have a few more seconds for the touchdown, align with the runway heading. Over here we're gonna make a very nice landing, idle thrust. So we have the flare here, the flare in the runway, flare, very beautiful flare touchdown, parking brakes and full thrust reverse. Over here we have full thrust reverse, align with the center line as you can see, and we're slowing down right now. So you can see outside just landed. You can see all the landing gear parts are perfectly safe. There is no breakage of either landing gear or nose wheel. Everything is normal. We are ready almost to exit the runway. So you can see the aircraft is standing up in its wheels, just the way it should be. There's no breakage. So here we are, just landed. So we come here, disarm the thrust reverse,